In this video, I'm going to show you how to obtain the sine law, when to use it, and how to use it. Before I do that, let's review how to solve a right triangle. Solving a right triangle means to find the length of all three sides and the value of all three angles. Now, if possible, you should use the information that is given instead of the information that you find, in case if you find incorrect information or if you solved it incorrectly, then that will affect all the values afterwards. You can use the Pythagoras theorem and the primary trigonometric ratios when you're solving right triangles. So let's take a look at this example here. So we have that angle C is 27 degrees. And remember that we label sides A, B, and C by where the angles are. So since this is capital A, the side opposite is little a. This is angle C, the opposite side here is little c. Capital B is where the right angle is, so the opposite side is little b. So let's first use our triangle to find the value of the lowercase b, or the hypotenuse. Now we can't use Pythagoras because we don't know what c is, but we can use trigonometry. So I have the angle 27 degrees, and I know that the adjacent side is 15, and I'm going to look for the hypotenuse. So in order to do this, we're going to use the cosine function. So cosine function says that the cos of the angle, which is 27 degrees, is equal to our adjacent side, which is 15, divided by the hypotenuse side, which is b. So we're going to multiply both sides by b, and then we're going to divide by cos 27 degrees, so b equals 15 divided by cos 27 degrees, and you can type that into your calculator. So b is equal to 16.83 centimeters. So you're going to divide 15 divided by cos 27, and make sure that your calculator is in degree mode. Now that I know that b is 16.83, I can also now find c, and to find c, based on the value that we have, the angle here is 27, the opposite is now c, and the adjacent is 15. So we're going to use the tan function. So tan 27 degrees is equal to the opposite, which is c, divided by adjacent, which is 15. So c is equal to, multiplying 15 on both sides, 15 times tan 27 degrees, so c equals 7.64 centimeters. So I found all three sides, or I have all three sides, and what I have left is to find the angle A. So angle A is equal to 180 degrees, because I know that all the angles that add up in a triangle equal to 180. So 180 minus 90 minus 27 gives me that angle A is equal to 63 degrees. So this leads to the question, what if we are not solving a right triangle, but we're solving a triangle that does not even have a right angle at all? And these triangles are called oblique triangles. So oblique triangle is a triangle that does not contain a right angle, such as what we have here. So I'm going to show you how to obtain the sine law instead of just telling you. So we need to label this triangle here. So let's say we have triangle A, B, and C. And I'm going to draw a height from the vertex A to a point D on the other side. So I'll call this the height. So we're going to do kind of a little bit of a formal proof here. So let AD be perpendicular to BC. So this upside down T is a perpendicular symbol. I'm also going to let AD equal H, so then it's easier to state the value. All right, so based on my labeling of capital A, B, and C, this length over here will be little a. This is angle B, so the opposite side here is little b. This is angle C, so opposite here will be little c. All right, so let's take a look at triangle A, B, and D. So this is the left-right triangle here. So in triangle ABD, I know that sine B, so sine of B, is equal to the opposite, which is H, divided by the hypotenuse, which is C. So I can say that H is equal to C times sine B. All right, let's take a look at the right side of this triangle. So in triangle ACD, so this one over here, I can do something similar. So I'm going to say that sine angle C is equal to the opposite, which is H, divided by hypotenuse in this case, which will be B. So H divided by B. So opposite divided by the hypotenuse. So isolating H here, we get H is equal to B times sine C. Now, since both of these equations equal H, I can say that C times sine B is equal to B times sine C, since both of these equal H. All right, then what I'm going to do is I'm going to divide both sides by BC. And when I do that, the C's will cross off on the left, the B's will cross off on the right. So I have sine B divided by lowercase b equals sine C divided by lowercase c. And this is the sine law. Now we can do something else. I'm going to put or. Let's start with this part again, what I have in blue. So C sine B equals B times sine C. Okay, this time instead of dividing by BC, I'm going to actually divide by sine B times sine C on both sides. And by doing this, I see that my sine B's will cross off on the left, sine C's will cross off on the right. So I'm left with little c over sine C equals little b, or side length b, over sine B. So you'll notice that that's similar to what I have on the left side here, except that the fractions have been reciprocated. So we can actually say that sine B over B equals sine C over C, and if we take the reciprocal of both sides, they will still be equal. Now, one more note, we can draw this altitude from any point. So I drew an altitude from A to the other side, but if I started at B and I draw an altitude from the vertex B here to the other side, we can show something else that's similar. So by drawing an altitude from B, you can show that sine A, capital A, divided by the length A is equal to sine C divided by the length C. So seeing that all of these are now equal, sine A over A equals sine C over C, which also equals sine B over B, we can now put all three of these together to give us the sine law, which states that sine A divided by little a equals sine B divided by little b equals sine C divided by little c. Now when I say A, B, and C at the top, those are angles. And the little a, b, and c, the lowercase a, b, and c, those are the lengths of the triangle. We can also take the reciprocal of everything. So length A divided by sine A equals length B divided by sine B equals little c, or length C, divided by sine C. And this is called the sine law. So let's take a look at an example of how to use this. So I have this oblique triangle here, and I want to solve it, which means I need to find the missing angles and the missing side length. So I don't have angle C, I don't have angle A, and I'm also missing this side here, and this side is actually opposite the angle C. So we're going to call this little c. So what I can do is, I know that these two, this angle is opposite the 27, so they match up. And then I can see that the 16, that's the side length of this angle over here. So I'm going to find angle A first. I can't actually do anything about C because I don't know the side length and I don't know the angle. So because I don't know both of them, I can't find them yet, but I can find angle A by using the sine law. So I'm looking for the angle, so I'm going to use sine A divided by its side length, which is 16, equals sine 136 degrees divided by 27. So I'm going to multiply both sides by 16 to isolate the sine A. So I get 16 times sine 136 degrees divided by 27. And then to type this out, I want to go A equals, I'm going to type out this whole right side, and then I have to remember to activate the inverse sign. So activate the inverse sine button on your calculator, and then we find out that angle A is equal to 24.31 degrees. Now when I type it out, I actually go 16 times sine 136, all divided by 27, press my equals, and then I activate my inverse sine. But you can also type it all in like this as well. All right, so now that I have angle A, I still can't find the length of C, but I know that the angle sum of a triangle is 180 degrees. So I can actually now find angle C. So angle C is 180 minus 136 minus 24.31. So angle C is equal to 19.69 degrees. Okay, so now I have left little c or length c. Now the only way that I can find this is to use this angle that I found from before, the 19.69, since angle C is opposite the length C. So to find the length C, I'm actually going to use the second version of my sine law since I'm looking for the side length. I like to place the unknown that I'm looking for on the numerator so that it makes it easier to multiply and solve. So I'm going to say C divided by sine 19.69 degrees, because that's the opposite length versus the opposite, or sorry, divided by sine of the angle, that's opposite it, equals. Now I'm going to use the same green one that I've circled here because those ones I already know. So that equals 27 divided by sine 136 degrees. And I'm going to multiply both sides by sine 19.69. So I get 27 times sine 19.69 degrees, all divided by sine 136 degrees. Oh, and then C, little c, is equal to 13.10, and that's going to be in meters. So to find little c, you simply have to type all of this in. You don't have to activate any inverse button, but just say 27 times sine of 19.69, and then divided by sine 136, and then press your equal sign.